Right. So today we'll see one of the most important topic, so which is typecasting. So let us try to understand what is typecasting and how many ways we can do typecasting, and how can we do typecast primitive data types, and how we can typecast objects. So there are different concepts are there. So we'll see in the today's session step by step. So very simple way of understanding typecasting means what? We can convert the type from we can convert the data from one type to another type. Okay, we can convert the data from one type to another type, which is basically called as a typecasting. Okay, and again in the typecasting, we have two kinds of a typecasting. We can call it as a upcasting and then downcasting, or we can say converting type of data, which is called typecasting. And there are two kinds of typecastings. One is upcasting, which is also called as widening process. Okay, widening. And second is downcasting. Just a second. Downcasting. This is also called narrowing. Just a second. So upcasting, which is also called widening, downcasting, which is also called narrowing. So these are the two types of typecasting techniques are there in Java. So upcasting and downcasting. And this upcasting and downcasting, both castings are applicable for primitive types and also object types. Okay, we can also use it for primitive data types and also objects. That means it is applicable for object-oriented programming also. So now we'll see with an example. First, we'll start with the primitive data types. We will try to understand what is upcasting and downcasting. Then we will apply the same concept for objects. Okay. So first of all, let me just go to Eclipse directly and create new package. Today, day 18. Okay, now in this package, I'm going to create new class. I'll name it as typecasting concept. Typecasting concept. I'm taking main method. All right. So first of all, let us see typecasting of primitive data types. So first of all, what is a typecasting? So as I said, first one is upcasting. Means what? Converting the data, or we can convert the we can convert the data from smaller type to higher type, smaller to higher. Converting data, or we can say converting value. Just a second. Converting value. Okay, for converting value from smaller to higher, smaller to or larger. Okay, so we have a different type of data types, right? We have a byte, short, int, long, double, float. There are different data types are there. So we are going to convert the value from smaller type to higher, or smaller to larger, which is called upcasting. Same opposite of downcasting is what? Converting the value from larger to smaller. Larger to smaller. Larger to smaller, which is called downcasting. Okay, downcasting. Upcasting means what? Converting the value from smaller to larger type. Downcasting means converting the value from larger to smaller type. So let's see some example. If I look at the upcasting example, let's say I have some data which is in integer format, and I can convert this into long format. Okay, or long format. Well, look at here, which one is higher size, integer or long? Long in the sense long int. Int or long, which one is higher? Long is having higher size. So here what exactly we are doing, we are converting from smaller type to higher type, or smaller to higher, okay, or smaller to larger. So this is called upcasting. Upcasting means what? Lower to higher or smaller to larger, which is called upcasting. Same thing, downcasting means what? For example, let's say, or we can take another example. Let's say I have double type decimal number that I want to, okay, I'll say float. Just a second. So let's say I have a float. Float is another type, right? So float is another data type. Now, if I convert float to double, which one is lower, which one is higher? Float is a smaller type. Float is a smaller type. Double is a higher type. We can store more value in the double, right? So smaller to higher. So float to double. If I convert from float to double, which is also upcasting. So basically, casting means what? Converting the value from one type to another type. Again, in the upcasting means lower to higher. Int is a lower data type. Long is a little bit higher than int. Same thing, float and double. Float is a lower type. Double is a higher type. So smaller to larger, which is called upcasting. Same opposite of this is downcasting. So for example, if I have a long type or long int, from that we can convert to the int. Int is a lower type. Okay, so larger to lower, you're downcasting it. Actually, downcasting means higher to lower. And same thing, for example, let's say double is a higher, that we can convert into lower, which is float. Double to float, this is called downcasting. Upcasting and downcasting. Upcasting means what? Converting the type from smaller to larger type. Downcasting means converting the value from larger to smaller type. So this is a theoretical definition. So now we'll see, just a second. Yes, can you see my screen? Okay. Can you see my screen? Okay. All right. So this is a basic understanding. Is upcasting means what? Converting the value from smaller to larger. Downcasting means converting the value from larger to smaller type. Okay. Now we'll see an example. So let us say upcasting is an automatic process. Upcasting is an automatic process. Means what? We can directly store integer value into the long, and we can directly store float value into the double. So it is an automatic process. We don't need to do any extra thing. But when you do downcasting, we have to do casting. So we need to do this downcasting explicitly. That means manually we have to do it. And upcasting is an automatic process, and downcasting is a manual process. That means we have to explicitly do the downcasting. So let me show you an example. First, we'll see upcasting. Upcasting is nothing but what? It is an automatic process. We no need to do any extra thing to do upcasting. Okay, means what? Smaller to higher or smaller to larger. Upcasting means smaller to larger. Now I'm taking one variable called int value equal to some 100. So this is my integer variable. Okay, and which one is a larger type than integer? We have a long or long int. You can take anything. So now I'm taking one variable called long, and long value equal to int value. Can you do like this? Is it correct? So what exactly I'm doing is I'm assigning the integer variable into long variable. Okay. So integer value is a smaller value. Long is a higher value. It can hold higher value, right? Because long is having more space than integer. So smaller value I'm assigning into higher value. That means smaller to higher. smaller to or larger, which is called upcasting. Okay. So now if you just want to print the value of long value, you can just print it. This is upcasting. So this is automatic process. We don't need to do anything when you do upcasting. So we can assign the lower value to the higher variable. Example, we can assign the integer value to the long because long is having more space than integer. Okay, this is upcasting. And are we doing anything here extra? Nothing. We are just assigning the value into the another variable. We are assigning the variable into the another variable. That's it. We are not doing anything extra. So this is automatic process. So upcasting is a automatic. We can just assign the lower type value to the higher or smaller to the larger, which is called upcasting. So let me show you another example. So let's take a decimal number. Float value equal to 10.5. Okay, can we declare the float variable like this? Float is nothing but what? It can hold a decimal number. Can we define the variable like this? Float value equal to 10.5. Float value is nothing but just a variable name. So we need to assign something called literal. Okay, whenever you are working with a float, we need to use a literal. So let's say f, uppercase or smaller case f, we need to put at the end of the value. Now, can I store this float into double? Let me take one more variable called double. Double value equal to float value. Can we do like this? Yes, because double is a higher type than float. Double is a higher than or larger than float. So the float value I can assign into double. This is a direct approach. We are not going to do anything else. Okay, we are directly going to store a smaller value into the larger value. This is also called as upcasting. This is also upcasting. Example for upcasting. So we are basically storing a smaller value into larger. That's called upcasting concept. Okay. Let me show you a downcasting example. So upcasting means what? We can store smaller value into the larger. Now downcasting is exactly opposite. Downcasting. This is not automatic. We need to do manually. And downcasting means what? We can convert larger type to smaller type. Larger type to smaller type. Let's see some example. So this time I'm taking long variable, long value equal to, I'm taking a big number like this. Okay. Now I'm taking one integer variable, int value equal to long value. Can we do like this? Int value equal to long value. So the problem here is in the downcasting, the major problem is in the upcasting, what exactly we are doing? We are assigning the lower value into the higher variable. Okay, for example, let's say, so this is a variable or this is a space I have. Let's say this is a space and this is higher space. Can we store this into higher space? Smaller thing we can store into higher, right? So smaller we can store into higher. So this is what upcasting, which we have understood. So smaller value we can store into higher variable. So upcasting, this is possible. So this is automatic process because there is no problem in this. Because small item we can put into the larger basket, right? This is no problem here. Upcasting is automatic. But when you want to put larger item into smaller thing, this is a downcasting. So here the problem comes. So we want to store the larger thing in the lower thing or the smallest container. So what is the problem in this? So first of all, can we put like this, the larger value into the lower variable? We cannot put. First of all, we cannot put. But how we can do it? We have to reduce the size. Okay, one way is what? We have to reduce the size. We can make this as a small size and then we can put it. So to reducing this part into smaller size, we can call it as a casting here. And also when you're trying to reduce this big one into smaller size, there is a chance of missing or truncating some values. Okay, because we are trying to reduce this into smaller size before storing, right? So whenever you're trying to reduce this into smaller size, there is a chance of losing some values or losing some or truncate some data. That possibility is always there in the downcasting. Okay. I hope now you understood. Upcasting means what? Smaller to larger. Downcasting means what? Larger to smaller. So larger to smaller is always a problem. So that is the reason we have to reduce this into smaller size and then we will store into variable. So what we can do now is we have to reduce it. How to reduce? So long value I'm going to store into integer variable. That is the reason here we have to put something called int. So now what will happen is the long value, whatever we have taken here, that will be converted into integer format and then it will store into integer variable. Okay, so this is called downcasting. We are storing the higher value into the lower variable, but normally it is not possible. So what we are doing here, we are converting or we are reducing the longer value into the lower value, and then we are storing into the lower variable. This is called downcasting. We are trying to reduce the level. So upcasting and then downcasting. Okay, and this is manually we have added this. This is explicitly we have to do it. It is not automatically done. Okay, so this is a concept of upcasting. I'll tell you where we have to use just a moment. Let me first make you try to understand. So downcasting. So let me show you another example. Next, suppose I'm taking a decimal number. I'm taking a double value. This is a decimal number. Let's say 125.55. So this is a decimal number, double. And I'm taking one float variable, float value equal to double value. See this? I'm trying to assign larger value into the lower variable. Larger to lower we are converting. It is not possible. So what we need to do now, first we need to reduce the size of the value. For that, we need to specify casting like this. So we will convert that into float and then I'm storing into the float. Okay, what exactly we are doing? So double means it is having higher value that we are reducing and storing into the float. So higher to or larger to smaller, which is also called as a downcasting. This is also an example for the downcasting. And again, what is the problem in the downcasting? Suppose in this double value, it can hold larger value, right? Suppose if you are storing a big value like this, but this much of value float cannot hold. In that case, what happens? Some value to be missing or some value will be terminated. After that, the value will be stored into the float variable. So there is a chance of missing or truncating the original value. So there is a problem in the downcasting. Okay, if I take smaller values, no problem. But if I take larger values, you may face this kind of an error. So this is also called as a downcasting. Now, I will write something here. You guys can tell me which is upcasting or downcasting. Okay. So I'm taking one more example. You mentioned the data type after the variable name. Will there be an impact? So this particular data type after the variable name. Okay, we'll see. Okay, so let me put this here. Okay, we can't specify like this. Okay, the type casting means that should be before the variable. That should be before the variable like this. Okay, now we'll see the one more example. You guys can tell me whether it is an upcasting or downcasting and what is the problem we will have in the downcasting. We will see this. I'm taking one integer variable int I equal to 100. Integer variable I'm taking int I equal to 100 and I'm taking double d equal to I. First of all, is it possible or not? Integer and double. Can we store integer value into the double? Yes, because both are numeric types only, right? Both are numeric types. But integer cannot hold decimal number. But double can hold integer, right? So double is a higher than integer always. So what we are doing, we are storing smaller value into higher variable, smaller into higher. Now, is it upcasting or downcasting? It is obviously upcasting. So this is an automatic process. We are not going to do anything. So now let us print the value of D. Okay, what is the output you are getting here? Value of D. We are converting integer to decimal. So as soon as we convert this to decimal, by default, it will add decimal number. So here you will get 100.0. Okay, now I will show you another example. This is called upcasting. Upcasting. So now let's see another example. Example 2. Right. So this time I'm taking double. See, now you'll understand the problem with the downcasting. Okay, double D equal to 10.5 I'm taking. Okay. And then I'm taking one integer variable int I equal to D. Can we do like this directly? No, because the double is a higher, integer is a lower. We are trying to store larger value into the smaller variable. So it is not possible. So how can we do this? We need to reduce the size. So we need to put typecasting int. So we can convert this double into integer and then we can store into I. Then what is the problem in this? When you print I value, the decimal part will be terminated. Okay, so we will not get the actual value, which is 10.5. So this is a problem which we have in the downcasting. So this is also called as downcasting operation, downcasting. Okay, so guys, now we understood what is upcasting, what is downcasting. Upcasting and downcasting. So we'll apply the same part, we'll apply the same thing for objects and object-oriented programming also. So once you understand, then I'll tell you when exactly we use upcasting, when exactly we use downcasting. Okay. So this is the concept. Very simple. Upcasting and downcasting. So upcasting is nothing but converting the value from smaller to larger type. Downcasting means converting the value from the larger to smaller. So to do upcasting, you don't need to do any extra thing. You can just assign the value directly. So this is automatic process, but downcasting is what? In explicitly, we have to specify the data type because we are trying to reduce the size of the value. Okay, this is upcasting and downcasting. Now, let us try to apply the same concept for object-oriented programming or the objects. How it is going to work for the objects. Now, most important, little bit confusing topic, but you need to carefully listen. Primitive types, it is very simple, but when you come to object type, you need to follow certain rules when you do the typecasting. Okay. Let's say typecasting for objects. I'm taking this another example. Typecasting objects 1. So if you trying to do typecasting for the objects, how it is going to work? Let me create few classes here because I need to create an object. If you want to create an object, there should be some class. So we can also apply the same typecasting concept for predefined objects, predefined classes also. So I'm going to create some user-defined packages. Let's see. I'm creating one class called parent class. And in this, I'm taking one variable called string name equal to, let's say, John. And also I'm creating one method void m1. And in this, I'm going to print something called, and this is m1 from parent. Okay, this is implementation of parent class. Now I'm going to create another class called child class. And in this also, I'm taking one more variable called int id. I'm directly assigning the value also. Then void m2, I'm creating one more method called m2. In this, I'm going to print this is m2 from child class. Okay, this is the implementation. So now this child is extends from parent. So now is there any relationship between child and parent? Is there any relation between parent and child? Yes. So the parent is child, there is a relation now. Okay, so this child is extended from the parent class. So whatever the child we created, which is having everything from the parent. Okay. Now let us try to do the upcasting and downcasting of the const typecasting for the objects. Okay. Now let us see the example. Come to the main class. Okay. In the main class, what I will do is I'm directly going to create an object for the child class. Observe very carefully. I'm just going to show you multiple combinations. So normally what you will do if you have a parent class and child class, normally which class we will create an object. If you want to access everything, child class we will create. Okay, let's create a child class object. Child C equal to new child. Okay. So when you're creating an object for the child class, we'll be able to access everything from child and we'll be able to access everything from child as well as parent. So now what I can do is by using the C object, I can access name. Actually, this is coming from which class? Parent class. Okay, which is coming from the parent class. Perfectly fine. We're able to access. Now, can we access C dot M1? M1 is also coming from the parent. Yes, we can still access. And similarly, can we access C dot ID? Yes, because IDs belongs to child class itself. So this is coming from child class. We can access C dot M2. M2 is also coming from the child class. So we can also access. No problem in this. So when you create an object directly, object is child class and reference variable is also belongs to child class. Both are same. Okay. Object is also child class. Reference variable is also child class. Both are same. There is no difference. So we're able to access everything from the parent and the child. So in this, there is no problem at all. Okay. Now I'm going to show you something here. Let's comment this. This is one approach. Now, what I'm going to do is here, I will say, I'm going to create reference variable of parent P equal to new child. Can we do like this? Is this correct syntax? Parent P equal to new child. Obviously. Why? Because parent class reference variable can hold child class object. Okay, remember always. Parent class reference variable can always hold child class object. Okay, what type of casting it is? Upcasting or downcasting? Child is the smaller, parent is a higher, because child is derived from the parent, right? So what kind of casting it is? Downcasting or upcasting? We are storing the lowest object into the higher variable. Parent is higher, child is a lower, or parent is a larger, child is a smaller. So we are trying to store smaller object into higher variable, right? So this is possible. So this is called what? Upcasting. We are doing upcasting. Okay. So when you do this, what we can access, what we cannot access. So let us see this. What we can access, what we cannot access. If you do like this, parent P equal to new child. If you create like this, object is what? Child class object. Variable is what? Parent. Okay. Now you tell me, can we access same thing I'm going to write? Okay. So same thing. System.out.println. Let me comment this first. System.out.println. P.name. Can we access or not? P.name. Yes. See, the problem here is when you do upcasting, we are storing the child object into the parent. So what we can do is, whatever the variables and methods are there in the parent, right? Only those variables and methods we can access. Even though the object is created for the child, we cannot access everything from the child. We can access everything from the parent only. Why? Because the variable is a parent. Okay. So if you're trying to access name from the parent, yes, we can access. This is perfectly fine. And when you're trying to call M1 method, P.M1, yes, still you're able to call because name and M1 belongs to parent. But observe, when you're trying to access ID and M2 method, we cannot access. Here it is giving an error. Why? Because even though the object is got created for the child class, but the reference variable is what? Reference variable is a parent, right? So that is the reason we are able to access variable and method only from the parent, but not from the child class. So here we cannot access. This is a problem in the upcasting. We cannot access. So we cannot access. Okay. So when you're trying to access the variables and methods from the parent class, we can access. Why? Because the reference variable is a parent. But from the object, we cannot access anything. ID and M2, these two are belongs to what? Child class. So we cannot access them. If you have created reference variable for the parent, we can access only the stuff from the parent. We cannot access anything from the child class. Okay. So this is one example. Okay. Now let's do the downcasting. So now this time what I will do is child C equal to new parent. Now tell me, is it correct or not? Child C equal to new parent. We are trying to store the larger object into the lower object. Downcasting. And when you do downcasting, we have to do explicitly, we have to specify what we need to specify in the downcasting. What we need to specify? The variable we have to specify. Okay. So what we can do is first let's create one parent variable, parent P equal to new parent. Okay. And then what we can do now, this P, I'm going to assign into C. So parent P equal to new parent. So I have created an object for what? Parent. Now I'm trying to assign this parent into child. So higher to lower, higher to lower. So when you do higher to lower, what we have to do? We need to do typecasting. So which class we have to specify here? Which class we have to specify? Child. Got my point? So we are trying to store higher into lower, which is called downcasting. So when you do downcasting, explicitly we have to specify the child class. We are reducing the size, parent to child. Okay. So now by using the C object, what else we can access now? Can we access C dot name? C dot name. Yes, we can access. System.out.println. Can we access C dot ID? Yes, we can access. Then C dot M1 we can access. C dot M2 also we can access. So this is a solution. So in the downcasting, we can access everything. Now what is an error it is giving? Class cast exception. See the problem. We are not getting any error, compile time error, but at the runtime we are getting an error here. This is a problem with the downcasting. At the runtime we are getting an error. So why we are getting an error here means this is a parent class object. And we are trying to store that parent class object into child class. Also, we have done the typecasting. So why still it is not working? So compile time, there is no error here, but only at the runtime we are getting an error. Why we are getting runtime? Because P is what? Parent class variable. And what is an object which is referring actually? Parent class object, right? Parent class object, it is referring. So the parent class object and child. Child is a lower than P. Child is a lower than P, right? So at the runtime, this one and this one is having a mismatch. So that is the reason it is giving a typecasting exception. Typecasting exception. Okay. So parent P equal to new parent. In another way, I can store. So for example, let's say we have seen this combination. Parent P equal to new child. Parent P equal to new child. Child C equal to new child. So in this, there is no problem. But in this, there is a problem. When you do the downcasting, there is a problem. Okay, so this is called downcasting. This is called downcasting because we are trying to reduce the parent into the child. Okay. So this is the problem. We can access name and ID M1, M2, but at the runtime, we will get an exception when you're working with the downcasting to the objects. Okay. So when we have to use this approach and when we have to use this approach. So let me tell you something here. Child C equal to new child. So this is one type of notation we are using. And parent P equal to new child. This is another type of notation we are using. So both are correct, right? So both are correct. This is the equivalent class, no problem. Here in this, there is no downcasting, there is no upcasting. Because the same object we are storing into the same type of a variable. So there is no downcasting, there is no upcasting here. But in the second option, what we are doing here, we are doing upcasting. So lower value we are assigning to the upper. So this is the one. Okay. Now, when we have to use this approach, Okay. So to understand this, I will give you one more example. With that, we are trying to understand. Let us say I have a small array. Okay. Let's say I am taking one array here. And this array contains a different type of data. So let us say you can consider this an array or array list, whatever. So here I have an integer value. Here I have a decimal value. And here some character. Here some string value. Here I have some Boolean value. Okay, this is my array. And in this array, I don't know what type of data we have. Okay, what type of data this array contains, I don't know at the runtime. But what I'm doing at the runtime is I'm trying to extract something. Let's say A of, let's say this is 0, 1, 2, 3, 4. A of 2 I'm saying. When I say A of 2, what is the value you are getting here? A of 2 means what? A. It will return the character. Okay. Suppose if you are not aware of this data, like what type of data you are having in this array, right? If you want to store this value in some other variable, so you don't know what type of data you are getting from A of 2. A of 2, what type of data you are getting? This is an array, right? From A of 2, what type of data? It can be written integer, it will return decimal, or it will return character or string. You don't know that. Okay, you don't know what is exact value, what is a specific value you are returning. In that case, you will specify generic type. Generic type is nothing but an object, because you don't know exactly what type of data you are getting here, right? Object is what? Object is a root class of all the classes, or root type of all the types, right? It can hold everything. It is a parent or super parent of everything in Java. So if you don't know exactly at the runtime, if you don't know exactly what type of data you are returning or what type of data you are getting, then you specify the object. Okay, this is a super parent of all the classes. Okay, for example, A of 3. So in A of 3, we have a string. So this time I know exactly this will return a string. If I know it is returning a string, then what I will do, I will define X is a string directly, right? So if I don't know what is a type it will return, then I will use object. If I know what is a value it will return, then I will specify the exact type. If it is written a string, then I will specify string. If it is written integer, I will specify integer. If it is a written Boolean, then I will specify Boolean. But if you don't know what type of data it is returning, then you can specify the object or any parent which can hold this one. Okay. Now you understand this scenario, everyone, right? When we have to specify this object, when you have to specify the specific data type. If you know exactly what type of data it is returning, you can specify that. If you don't know what type of data it is returning, you don't know, then you can specify this. Same thing is applicable here. So suppose if this object is returning, what exactly this object is returning, if you know that, you can directly specify here. Child it is returning, so I'm just specifying the child variable here. The reference variable is also child. Okay, suppose if this object returning something, but we don't know exactly what it is returning, right? Then instead of specifying the exact same type, you will specify the parent. because the parent can hold child, right? Parent can hold child. So if I take parent reference variable, this can hold parent type of object and also child type of object. Parent type of object and also child type of object. So if you know exactly what type of object you are returning, you can specify that as a, you can specify with the same type. If I don't know exactly what is returning, you specify that as a generic type. Another example I will take. Suppose I'm taking here s equal to welcome. S equal to welcome. Okay, now we are storing this value into the s. So you know exactly this is a string. Then you can specify s is a string. This is the direct. This is the direct. If you know what is the value which we have, so that you can directly specify the string. This is more specific. Suppose if you don't know exactly, suppose again welcome is there, but again you don't know exactly what type it is. Okay, for example, I'm expecting this value from the user. Okay, s value by using scanner class, I'm expecting this value into the s variable. But what type you will specify for this s? I don't know what type of value the user can enter. User can enter integer, user can enter float, or user can enter string. You don't know what type of value I will get at the runtime. So then what type you will specify for this variable? Object. Because this is the parent of all the parents, or parent of all the classes in Java. So it can hold everything. You understood now? So if you know specific data, if you know exactly what kind of value you are getting specifically, then you will specify that type. If you are getting string, you will specify the string. If you are getting integer, then you will specify the integer. If you are getting the double, then you will specify the double. It is more specific. But if you don't know what type of value you are getting at the runtime, you don't know, then you will specify a class which is a parent of all the classes, string, int, float, boolean, everything we can store into the object. Okay. So now you understood when we have to use this, when we have to use this. If this object is returning the, if you know what exactly this object is returning, then you can specify the type. If you don't know what exactly the object is returning, then you can specify the parent or object, anything. Okay. So this is all about upcasting and downcasting concept. Everybody is clear so far with this example? So we will see more examples about typecasting, because when you do typecasting objects, we need to follow certain rules and conditions. So we will discuss all those rules and conditions now. So I'll try to elaborate this concept and give you more examples so that you will be more familiar with this. So this is another important entry question. Okay, when to use this approach, when to use this approach. So child class object, we can always store in the parent class variable. This you have to remember. Child class object, we can also always store in the parent variable. Okay, so grandparent, no. If you have grandparent, can we use them? No. Grandparent, here, yes, here you can use grandparent, no problem. Parent of parent is called grandparent. So that is again, see, I'll tell you an example, one more example. Now you guys can tell me it is correct or not. Okay, so I have A class, B class, and C class. Okay. I will write multiple combinations. You guys can tell me with this correct syntax or not. A equal to A. Valid or not? Valid or not? Yes, this is valid. Now tell me, A equal to B. Valid or not? Valid or not? Yes or no? Valid. Why? Because child class object, B is a child of A, right? Child class object can hold in the parent class variable. Yeah, this is also perfectly fine. Now, can we do like this? Let's say A equal to C. Is it valid or not? It is also valid. Why? Because C is the child class of B. B is again child class of A, right? So A is higher than C or not? Higher. So object of C can we hold in A or not? Yes, obviously we can hold. Now B equal to C. Is it valid or not? B equal to C, valid or not? Yes, C is a child class of B, right? The object of C we can store in the reference variable of B. So the parent class object can hold child class. Perfectly fine. Okay, perfectly fine. Now B equal to actually we should say new keyword in every object. I have not specified new. Yeah, can we do like this or not? New A into B. I'm storing the larger object into smaller object, downcasting. So what we have to do in this case, here we have to specify B, typecasting. Typecasting is needed. Then only we can do it. Otherwise, no. Okay, now just observe here. B equal to new C. Valid or not? Is it valid or not? Valid. Why? Because C is a child, B is a parent. So we can directly hold child class object into the parent class object. So I hope everybody is clear. But when you do downcasting, what we can do is we cannot access certain variables from the child class. So that's the reason downcasting is not preferred most of the times. You understood the point, everyone? So now I'm going to show you some more examples, and we need to understand the rules first. When you do typecasting or upcasting or downcasting, whatever, we have to remember certain rules. Otherwise, you will get a compile time exception and runtime exception. Okay, so now let me show you some more examples of casting. So it is just a terminology, upcasting and downcasting, right? So let's go to the another example. So we will try to understand the rules. So this is not possible. Let me remove this first. Okay, either go with this one or go with this one. Now let me try to show you one more example. Typecasting objects. So when you do typecasting of objects, we have to follow certain rules. Okay, there are some rules are there. So we can use downcasting. We can still use downcasting for the objects, but there are some rules we have to follow. Okay, so I will show you what are those rules we have to follow, and accordingly we can do the downcasting. So now let me show you something like this. So forget about downcasting, upcasting. Those terminologies are not much important. Just understand the concept. Upcasting means what? Lower to higher. Downcasting means higher to lower. It can be primitive type or it can be object. Anything is applicable. Okay. Now we have to know certain rules when you do or when you are working with the casting concept. Okay. So what are the rules and regulations we have to follow? So, but before that, I'm going to create a few classes here. Class animal. Okay. I'm not adding any variables and methods. I'm just want to show you the typecasting. Okay. So animal is one class. Can we create a class like this? One single line. Because I don't have any variables and methods. So instead of keeping these brackets in multiple lines like this, right, I can put them in the one single line. One single line is enough like this. If I don't have any variables or methods, just if you want to just create an empty class, you can create like this. Okay. Now I'm going to create another class, dog, which is extends from animal. And this is also empty class. Now I'll create another class called as a cat, which is also extends from same class called animal. This is also empty class. Okay, this is also empty class. And so now one parent is having two child classes, animal, dog, and cat. So animal is a parent class, which is having two child classes, dog and cat. And is there any relation between dog and cat, these two classes? Any parent child or any relationship between these two? No. There is no relation between dog and cat. Both are two independent classes. Dog is derived from animal. Cat is also derived from the same animal class. Remember this. These two are the child classes of animal. Animal is a parent of dog and cat, but there is no relation between dog and cat. Remember this hierarchy. Okay, so now let us try to do the typecasting. Whenever you do the typecasting, we have to follow three rules. Okay, three fundamental rules we have to understand. If you understand these three rules, you can easily do the typecasting for the objects. Okay, so let us see what are the rules. And let's go to main method directly first. So here, what I'll do is I will create animal an equal to new animal. I am creating the object is also referring to the animal class, and the variable is also referring to the animal class. So both are same. Animal an equal to new animal. Instead of that, I'm taking dog. Can we do like this? Dog. Child class object we can store in the parent class variable. Perfectly fine. Child class object I can store in the parent class variable. Okay, perfectly fine. Now I will try to do the casting like this. Just observe. I say cat ct equal to an, and here I will say cat. So this is the kind of a casting I'm doing. And if you just observe this part, in this, an is what? Animal type of variable or animal type of object. Cat. And we are converting this an to cat, and then we are storing into the cat type of object. Okay. So whenever you do typecasting, in this expression, we will have, okay, in this expression, sorry guys. Yeah. In this expression, we will have three parts actually. If I look at this, there are three parts are there. Let me write it here. And we need to understand the rules first, okay? And then we will try to understand. See, in this expression, this is the first part, second, third, and fourth. Divide this entire statement into four parts. Okay, and let us call them with some names. Okay, let's say this is A, this is B, this is C, this is a D. And classes I'm representing with uppercase characters. Objects or reference variable I'm representing with the lowercase characters. So let us divide this entire expression into four categories. Let's say A, B, C, and D. A is a class, C is also class, B is a variable, D is also a variable. Okay, let's divide this entire thing into four parts. Now, based on that, let us try to understand the rules. What is the first rule? Rule one is, whatever variable we created here, what is the type of this variable? Animal. And whatever the class we specified here, this should be either equal to animal class, or it should be, or the first rule is what? There should be some relation between these two actually. The rule one is there should be some relation between C and D. D is what? A variable. C is what? Casting type. So if you look at this expression, the first rule is whatever variable you are using, this one and this one. So between these two, there should be some relationship. There should be equal, or there should be some parent and child relationship. If I look at this, an is a animal class of variable. Cat is what? Child class of animal. So both are having some relationship or not? These two are having some relationship or not? Yes or no? Yes, there is a relationship. So the first rule is, let me write it here. Rule one. When you do typecasting, we have to follow this rules. Rule one is conversion is valid or not. We have to check. Conversion is valid or not. Conversion means what? We are converting this into cat type. So this is called conversion. Here we are doing conversion. Is it valid or not? We have to check. So how to check this conversion is valid or not? So the type of D and C must have some relationship. So type of D and C means what? C and D means what? These two. These two. C and D means these two. Cat and animal. These two parts. So these two are having some relationship or not. If there is a relationship, the conversion is valid. If there is no relationship, the conversion is not valid. Now, is there any relationship between these two or not? Yes. AN is derived from animal only, right? Animal. Cat is a child class of animal. So relation is there. If the relation is there, then rule 1 is satisfied or not? Rule 1 is satisfied or not? Yes. So according to the rule 1, the first verification is what? The conversion is valid or not. The conversion is valid or not. How to check the conversion is valid or not? So the type of this AN and the type of this cat, both are having certain relationship. It can be parent and child, or it can be child or parent, whatever. There should be some relationship. Okay, then only the conversion is possible. This is the first rule. So in this example, this is valid as per rule 1. Okay, not only this rule, there are another 2 rules we have to check. Then only the typecasting is possible. So this is a rule 1. Everybody's understood about rule 1. So in this typecasting, conversion is valid or not, we need to verify. How to verify the conversion is valid or not? These two. What are these two actually? We are referring this as a D. This we are referring as a D. That's the reason I'm giving some names to this part. A, B, C, D. Okay, in this expression, C and D should have some relationship. If C and D is having some relationship, then this conversion is valid. If there is no relation between C and D, this conversion is not valid. So then rule number 1 will not be satisfied. So as per this expression as of now, the cat and AN, which is derived from animal class, both are having relationship. So this expression is valid. The conversion is valid as per rule 1. Okay. Now, next one. Suppose, let me write like this. You guys can tell me valid or not. I'm returning dog DG equal to new dog. Okay, now I have created an object for the dog class. Also, the reference variable is also dog class. Okay, now I'll say cat CT equal to DG. And here the conversion type is cat. Now tell me, is it valid according to rule 1? According to the rule 1, is it valid or not? According to the rule 1. C and D, that means these two are having some relationship. So what is a DG here? DG is a dog type of object. What is a cat? A cat is another class. So dog and cat, do we have any relationship? There is no relationship. So the conversion is not valid. Conversion is not valid. So according to the rule 1, this expression is valid or not? Not valid. Okay, this is invalid according to or as per rule 1. Okay, now you understood. So rule 1, this is rule 1. Again, we have 2 more rules. The first rule is what? C and D both should have some relationship. Then only the conversion is valid. This is the rule 1. Okay. Now, let us discuss the rule 2 when you do the typecasting. Rule 2. Rule 2. Let me write a point here. So what is a rule 2? Let me write something here. Animal AN equal to new dog. I'm writing object like this. And then I say cat CT equal to animal. And the conversion is called cat. Just observe very carefully. As per rule 1, is it valid or not? As per rule 1. Rule 1. Yes. Why? Because as per the rule 1, C and D both should have some relationship. So here cat and animal both are having relationship, parent and child relationship, because cat is derived from animal only, right? So rule 1 is valid. Rule 1 is valid. Now let us check the rule 2 is valid or not. In the rule 2, what we have to check is assignment is valid or not. In the rule 1, conversion is valid or not, we will check. Means C and D having relationship or not. Now in the rule 2, assignment is valid or not, we need to check. In the rule 2, assignment is valid or not, we need to check. What is an assignment? This is called assignment. We are assigning this into CT. that is valid or not, we need to check. But how to check? C must be either same or child of A. Here I am talking about C and A. C and A should be same, or C must be child of A. C must be child of A. What does it mean? If you look at this, after conversion, where exactly I'm storing it? After conversion, this become cat, right? Cat object. That we are storing into another variable. This variable also should be cat type. Why? Because we are storing the cat object into variable. So that variable should be what? Cat type of variable. You understood this point? The assignment is valid or not? The assignment is valid or not? So let me show you an example. For example, I'm taking one integer variable, some x equal to, okay, I'm taking one character variable, some x equal to, okay, a. Now I'm assigning the x, sorry. And I'm taking y, and then I'm assigning x. Is this assignment valid or not? Is this assignment valid or not? Assignment not valid. Why? Because x is a character, y is an integer. So x cannot store in the integer variable. Character value we cannot store in the integer variable. So this is invalid assignment, right? Same thing when you come to the object. Here, after conversion, it becomes a cat object. This returns a cat object. And if you want to store that cat object in a variable, that should be which type? Cat type only, right? Then only it can hold. So that is called assignment is valid or not. So the C must be either same or child of A. What is A here? This is called A, B, C, D, right? This is A. So the C is nothing but what? This is C. So the C must be same as A, or the C must be the child of A. You got my point? So this must be exactly same as this variable, or this must be the child of this class, because the child class object can hold in the parent class variable. Everybody is clear about this point, or is there any confusion? So in this rule 2, we are checking assignment is valid or not. Assignment is nothing but after converting this variable, what type we will get? Cat type. So if you want to store cat type in the variable should also be cat type or the parent of cat. It can be parent also. It can be animal also. No problem. Okay. So that is a rule number 2. Assignment is valid or not. C must be either same as A or parent of child of A. So that is a rule number 2. Okay. So this is valid. In this case, this is valid or not according to the rule 2. Is it valid or not? Is it valid or not according to the rule 2? As per rule 2. Rule 1, anyway, it is valid because AN is an animal, C cat is a child class animal. Both are having relationship. So rule 2 anyway satisfied. Rule 1 is anyway satisfied, but I'm talking about rule 2. So whatever the type we are storing into the variable, so this should be same type. So when you're storing the cat type of variable in this variable, then it should be also cat type. Okay. So this is valid as per rule 2. Now I'll show you one more. Then you can tell me whether it's valid as per rule 2 or not. So I'm creating one variable called animal, an equal to new dog. Okay. Now cat ct equal to dog. And now tell me, is it valid or not? First, check the rule 1. As per the rule 1, it is valid or not. As per the rule 1, is it valid or not? So rule 1 is what? These two are having relationship. So animal is derived from animal. Dog is a child class of animal. So both are having relationship. So rule 1 is satisfied. Rule 1 is satisfied. Now what about the rule 2? We are converting this into dog, but storing into what? Cat type of variable. Cat type of variable. So what is the rule 2? Conversion is rule 2. Assignment is valid or not? How we can check? The C is nothing but this one must be either same as this one, or the dog should be child of cat. Right? So there is no relation between these two. So rule number 2 is failed. So this is invalid as per rule number 2. Rule number 2, it is invalid statement. Understood, everyone? Why it is invalid according to the rule number 2? Because we are storing this dog object into something else, which is cat. Cat and dog, there is no relation. That's the reason as per the rule 2, it is invalid. So what is the rule 2 assignment is valid or not? We need to check. Rule 1 conversion is valid or not? We will check. Okay. So these are the two rules. So these are the rule number 1 and rule number 2. Now, rule number 3. So rule number 2 understood, everybody? So don't go about variables and methods. Okay, if you include them, you will be confused. Just focus only on the typecasting part. And what are the rules we have to follow when you do typecasting? And once you typecasting, what and all we can access, that is a different thing. Okay, don't go that area. So just stick to this. Okay, when you do typecasting, what are the rules we have to follow? So first rule, I've shown you example. Second rule, I have shown you example. Now we'll go to the third rule. Third rule. Okay, so when you rule 1 or rule 2 is not satisfied, then you will get an exception. See, suppose rule 1 is not satisfied. So you will get a compile time error. Here itself, it will show you cannot cast from dog to cast. Okay, cannot cast from dog to class. If your rule 1 is failed or rule 2 is not failed, in both the cases, it will give you a compile time error. So you can just look at this. Even this is also invalid, right? So if your rule 2 is also failed, it will give you compile time error. But if rule 3 is failed, execution will happen. You will not get any compile time error, but you will get runtime error. So what is the rule 3? We will try to understand. So don't talk about variables and methods for now. Okay, just stick to only object typecasting. What are the rules we have to follow? That's what I'm saying. Right. So now rule number 3. What is the rule number 3? So rule 3 is the underlying object of type D must be either same or child class of C. So I'll tell you what exactly it is. The underlying object of type D must be either same or child of C. So let us try to understand this with an example. Again, I am creating animal class object equal to new dog. Okay, I'm storing the child class object into parent class variable. Fine. Now I'll do typecasting like this. Dog dg equal to casting a dog and then animal. So now tell me, is the statement valid or not? Or I can take this one. Oh, sorry, I can take this one. Cat ct equal to cat animal. Now tell me, is this statement is valid or not? This particular statement is valid or not? So are you seeing any compile time error here? Are you seeing any error in this? No error. But when you run this, you will get a runtime error. Okay, when you run this, you will get a runtime error. So what is an error? Class cast exception. Class cast exception. So if rule 1 and rule 2 is got failed, you will get a compile time error. But when your rule 3 is got failed, you will get a runtime error. You will not see any compile time error. You will not see any syntax error here, but you will get a runtime error. So now we'll understand what is the rule number 3. So the underlying object of type D, what is D here in this expression? AN, this is a D. So the underlying object of type D is what? The object of AN is referring to which? Dog class object. So AN is referring for what? Dog class type of object. So the underlying object of type D is what? Dog. Must be either same or child of C. What is C here? This is called C. This is D, this is a C. So what is the point here? The underlying object of AN is what? dog. And here it is what? Cat. Do you have any relationship between these two, dog and cat? No relation. So what is the point here is the underlying object of an should be same as this cat or the child of this cat. Okay, this should be same as a cat or this should be the child of a cat. Then only this rule will be satisfied. Now, as per this particular expression, is it valid or not according to the rule 3? According to the rule 3, is it valid or not? An underlying object of an is what? Dog. But what is the reference we specified? Cat. Is there any relation between the dog and cat? No. That is the reason this is invalid as per rule number 3. It is invalid as per rule number 3. Okay, the underlying object of D means this one. What is an underlying object of this animal? Dog. And the C means cat. Should have some relationship or should be same. Then only this statement is valid. So the underlying object is different. Here the casting object is different. So it is invalid as per rule 3. If it is invalid, you are not getting compile time error, but you will get the runtime error. So if you rule 1 and rule 2 is not satisfied, you will get a compile time error. When rule 3 is not satisfied, you will get a runtime error. That is a rule number 3. Okay. Now, you guys can tell me whether the typecasting is valid or not according to all the rules. Rule 1, rule 2 and rule 3. Okay. Now I'm combining all the rules. Rule 1, rule 2 and rule 3. According to all 3 rules, this statement is valid or not, you have to tell. Animal, I'm creating animal an equal to new dog. And now I'm doing the typecasting called dog dg equal to dog of animal. Okay, first. What is the first rule? What is the first rule? These two are exactly having relationship or not. So this is A, this is B, this is C, and this is D. So between these two, is there any relationship or not? Dog and animal, yes or no? Yes. So animal is derived from animal, an is derived from animal, dog is a child class of animal. So relationship is there. So rule 1 is satisfied. Rule 1 is satisfied. Okay, rule 1 is yes, satisfied. Now come to the rule 2. So after conversion, we are storing into this variable, right? And what type of this variable it should be? Dog type. So what type of object we are storing? Dog type of object. What type of the variable it should be? Dog. It should be same type or it should be parent type. Here we can also specify the parent of dog. So matching or not? Yes. Rule 2 is satisfied or not? Yes. So rule 2 is satisfied. Now come to the rule 3. What is the rule 3? The underlying object of this an. What is an underlying object of this an? Dog is an underlying object. And the conversion object. What is this? Dog. So both are same or not? Yes. Both should be same or it should be parent of this one. So rule 3 is also satisfied. So rule 3 is also satisfied. So if both 3 rules are satisfied, then only this typecasting expression is correct. Otherwise, even one rule is not satisfied, this typecasting expression is not valid. Okay, now everybody is understood about 3 rules. So when you do typecasting, all 3 rules should be applicable. Even one rule is not satisfied, that expression which we have written is not correct. Rule 1 is what? The relationship between C and D. What is the rule 2? First rule 1, as rule 1, these two are having relationship or not. Rule 2, assignment is correct or not. After conversion, we are storing into the right variable or not. The conversion assignment is correct or not. Rule 3 is what? The underlying object of an, that is new dog, should be same as this one or not. If these 3 rules are satisfied, then typecasting statement is correct. Otherwise, no. Okay. So if you divide this typecasting expression like A, B, C, D, then it will be clear. Rule 1 is what? Conversion is valid or not. How to check conversion is valid or not? Because both are having some relationship. And assignment is valid or not. That means whatever object we converted, we are storing into the right variable or not. That's called assignment is valid or not. Rule 3, the underlying object of AN should be equal or the parent of the cat class. That is a rule number 3. If 3 rules are satisfied, then the typecasting is correct. So now everybody's understood about all 3 rules, which are very, very important. So when you do typecasting for objects, you have to remember these 3 rules. Okay, if these 3 rules are satisfied, then object typecasting is correct. Okay. Now, in this example, we have seen the typecasting for objects which are user defined. We have created our own classes and objects, right? And how the same typecasting is applicable for predefined classes or predefined objects which are already exist in Java. So we'll see another example. Anybody's having any queries on this example before showing another one? Don't think about variables and methods, access levels and everything. Here just focus only on the typecasting part. We will see all the combination. Okay, I already told you when we have to use these 2 approaches. In this example, I already told you when you have to store this in the child class, when you have to use a parent class. 2 different situations, 2 different scenarios. If you exactly know what type of object it is returning, you can directly specify the exact name. And if you don't know what type of object it is returning, then you can just specify the parent. But what is the problem in these 2 approaches? In the first approach, we can access everything from child and parent. But in the second approach, we can access everything from parent, but not child. That is a limitation. Okay, if you have variables and methods, that is a process. Okay, now let me show you another example. Yeah, you can run it, no problem. Even if you run this now, you won't get any runtime exception or nothing because this is a valid step. I have not printed anything, right? So I'm not getting anything. In the next example, I will show you the values also. Okay, put some value variables and methods and we'll see that. So there is no runtime exception. There is no compile time exception. So if the rule 1 and rule 3 are failed, you will get a compile time exception. And if your rule 3 is got failed, your program will execute, but you will get a runtime exception if rule 3 is got failed. All right. So now let me show you one more example for predefined classes. So typecasting objects 3. Okay. So typecasting objects 3. Okay, so now this example, I will ask some questions. So you guys can tell me and don't forget the rule. Okay, so when you write a typecasting expression, this is the rule. This is a formula you can consider. A, B equal to C and this is a D. This is the expression, writing a typecasting expression, syntax of writing typecasting expression. Okay, now, so remember all 3 rules, rule 1, rule 3 and rule 3, rule 2 and rule 3. So we need to remember those rules before doing it. Okay. Right. So I'm going to show you some examples. You guys can tell me whether they are valid or not according to the rules. So before telling, you need to check the rules. Okay. Here I'm creating, here I'm using a predefined classes, predefined objects. So I'm not going to create any new classes. So I'm taking an object type of variable, object O equal to new string of welcome. Is it valid statement? Can we store string object into object variable? Yes, because object is a parent of everything, right? So we can store string type of object into parent class variable. This is perfectly valid statement. Okay. Now here I'm taking string buffer variable. String buffer is also one more predefined class which is available in Java. Okay. So string buffer SB equal to, and I'm doing some kind of a casting here. String buffer of wo. Now tell me, according to the rule 1, is it valid or not? According to the rule 1, is this statement valid or not? So what is the rule 1? Rule 1. Conversion is valid or not? And these two should have a relationship or not? Right? A, B, C, D. So C and D is having relationship or not? Yes or no? O is object type of variable. String buffer is another class. And this is also derived from the object class because object is a parent class of all other classes. So is there relationship or not? Is there any relationship? Yes. So rule 1 is passed. Rule 1 is satisfied. Rule 1 is satisfied. Okay. Now I will write something like this. Rule 1 is satisfied. And rule 2. Rule 2 is satisfied or not? Rule 2. What is the rule 2? After converting this, we are storing into some variable. And that variable should be same as this one or the parent of this one. Satisfied or not? Yes, it is same exactly. So rule 2 is also satisfied. Rule 2 is also satisfied. Now, what about rule 3? Rule 3. What is the rule 3? The underlying object of O is what? String. The underlying object of O is what? String. And what is the reference we are using? String buffer. String and string buffer. Is there any relationship? No, there is no relationship between string and string buffer. So the rule 3 is got failed. In this expression, rule 3 is got failed. You understood my point? Rule 1, rule 3, rule 3. So all 3 rules should be satisfied. Then only this expression is correct. Otherwise, wrong. Okay. This is one example. So you have to tell me. Okay. Now the second example. Let's take another example. Example 2. I'm taking string variable, string s equal to new string. And here I'm keeping some value. Okay, string s equal to new string. Now, string buffer variable I'm taking. String buffer sb equal to, string buffer sb equal to, casting is what? String buffer. And here I'll say yes. Now tell me, is it valid statement or not? Rule number 1. What's the rule number 1? C and D, these two should have a relationship. Do we have a relationship between these one? String buffer and S. String buffer is a different class. S is a string here. So it is a different class. There is no relationship. So rule 1 itself is got failed. Rule 1 is failed. If rule 1 itself is failed, we no need to check the other rules. No need to go with rule 2 and rule 3. There is no use, right? So rule 1 itself is got failed. So in this expression, rule 1 itself is got failed. So you no need to check rule 2 and rule 3. Now, another example. Here I'm taking object O equal to new string welcome. Right? Statement is valid because string is a child class of object. So the string object I can store in the object type of variable. So this is perfectly correct. Now I'm using something called string buffer. String buffer HB equal to casting is a string buffer and say O. Now tell me valid or not. First rule number 1. So rule number 1 satisfied or not? Rule number 1. Rule number is what? Rule number is 1 is what? These two should have some relationship. So string buffer and object is having relationship or not? Yes, because string buffer is again derived from object itself. So both are having relationship. That means what? Rule 1 is satisfied. Rule 1 is satisfied. Now, rule number 2. Rule number 2 is what? After conversion, we are storing into the variable, and the variable should have same type or the parent type. So currently string buffer and string buffer both are the same types. Both are the same types or not? Something wrong in this. String buffer. Is there any spelling mistake? Yes. Here is a spelling mistake. String buffer. Okay. Right. So rule 1 is satisfied because both are having relationship. Rule number 2 is what? After conversion, we are storing into the exact variable or not? Yes. So rule 2 is also satisfied. Rule 2 is also satisfied. Now rule number 3. The underlying object of O is what? String. The underlying object of O is what? String. And what is the reference we are using here is string buffer. So there is no relation, right? String and string buffer, there is no relation. So rule number 3, passed or failed? Failed. Rule number 3 is failed. So this expression is invalid. Even one rule is not satisfied, that expression, the typecasting expression is invalid. Okay. Rule 3 is not satisfied, but rule 1, rule 2 is satisfied. So this is one example. Now let me tell you one more example. Example 4. Example 4. Here I'm taking object variable, object O equal to new string of welcome. New string of welcome. And I'm taking string buffer SB equal to string is a typecasting. String. And here I'll say O. Now, rule number 1. Rule number 1 and 3 are not same. Okay, rule number 1, we are checking the relation between these two. In rule number 3, we are checking the underlying object. The type of this object is what? String. And this one. Okay, we are checking the underlying object. This one and this one should be same. That is the rule number 3. Rule number 1 is what? These two are having relationship or not? Direct. So O is what? Object type. String buffer is what? Child of object. So rule number 1 is satisfied. But rule number 3, string buffer is O. O is what? Underlying object of O is what? String is underlying object. So string and string buffer is not matching. That's the reason rule number 3 is got failed. Okay. Rule number 1, 3 is totally different. Now, see this expression. In this, rule number 1 is satisfied or not? Rule number 1. Yes or no? Rule number 1. There should be some relationship in this. So O is what? Object type. String is also child class of object. So relationship is there or not between these two? Yes. So that means what? Rule number 1 is passed. Rule 1 is passed. Now come to the rule 2. Rule 2 is what? After conversion, string should be stored in a variable, and that variable should be again either string or the parent of string, which can be object. So is there any relation between string and string buffer? After converting into string, we are storing into SB. SB is again string buffer. So this is not valid assignment. So rule 2 is also failed. Rule 2 is failed actually. Rule 2 is a failed. So if the rule 2 is got failed, we no need to check the rule 3 again. If rule 1 is passed, then only go to rule 2. If the rule 2 is passed, then only go to rule 3. Okay. So here rule 2 is got failed. So you no need to check the rule 3. So this is one more example. Okay. So now let me take another one. So you need to be more familiar with the 3 rules. That's the reason I'm telling all these examples. So next one, I'm taking string variable called s equal to new string, and here I'll put some value. And now I'm taking string buffer SB Okay, equal to casting is a string and yes. Now tell me rule number 1 is valid or not? Rule 1 passed or not? So the variable here, there should be relation between these two. That's the first rule. So S is what? String type of variable. Again, here also string, both are equal, right? So relationship is there. It should be same or should have a parent and child relationship. Anything is fine. So rule 1 is what? Passed. Now rule 2. So after converting into the string, we are storing into another variable that is again different class type. String buffer. So string and string buffer is totally different. So here also rule 2 is failed. Rule 2 is got failed. It is invalid as per rule 2. Okay. Now another example. Example 6. Example 6. Here I'm creating an object type of variable. Object O equal to new string of welcome. Object O equal to new string of welcome. So here O is a object is O, new string. So O is a parent class variable which can hold string. Okay, now I'm writing like this. String buffer SB equal to casting is also string buffer. Okay, and here I say O. Now tell me, rule number 1, passed or failed? Passed. Why? Because O is an object type of variable. String buffer is a child class of object. So both are having relationship, right? Relationship. So rule number is passed. Now rule number 2. Rule number 2. After converting, we are assigning into SB. So we are converting string buffer. We convert it into string buffer and storing into the same type of a variable, string buffer. Here also string buffer. It should be same or it can be parent. So rule 2 is also passed. Rule 2 is also passed. Now what about rule 3? So underlying object of O is what? String. The underlying of object of O is what? String. And here it is a string buffer. So string and string buffer not matching, no relation. So rule 3 is got failed. Rule 3 is got failed. Okay. Now another example. Example 7. Again, I'm taking object variable equal to new string welcome. Object O equal to new string of welcome. I'm just trying to make you understand the concept. That's the reason I'm giving more example. And certain things are similar here, but I'm just trying to make you understand about rule 1, rule 2, and rule 3. If you are familiar with this, you will be able to do the typecasting. Okay, don't compare this. Okay, these combination, if you are already using somewhere earlier, don't compare like this. Just check the rule 1, rule 2, and rule 3 prospect. So example 7, object O equal to new string of welcome. And here I'm taking a string variable, string S equal to string of O. Yes. Tell me, rule number 1, passed or failed? Rule number 1. Rule 1. Rule 1 is what again? There should be some relation between these two. String and O is an object. So there is a relation. So rule 1 is passed. What about rule 2? Rule 2, after conversion, we are assigning into AS. So after conversion, it becomes string and the variable is also string. So rule 2 is also passed. Rule 2 is also passed. Now, what about rule 3? Rule 3, the underlying object of O is what? String. And reference here is what? String. Both are same or both should have some relation. So rule 3 is also passed. Rule 3 is also passed. So this is the exact right statement to do the right typecasting. Okay, now if you're trying to print this, can we print this as variable? Can we print? System.println. If you print s, what is the value you will get? Same welcome you will get, because after successful conversion, because rule 1, rule 2, rule 3, all three rules are satisfied. So the typecasting statement is perfectly correct. So you will get an output like this. Okay. So now everybody is clear about all three rules. How to check all the three rules when you do typecasting. All three rules. How to check all three rules for the typecasting. So these are for predefined classes and predefined objects. Okay. So this is all about typecasting concept. It's all about typecasting concept. So we have seen what is typecasting, upcasting and downcasting. Also, we have seen typecasting of primitive variables. Also, we have seen typecasting of predefined classes. Also, we have seen typecasting of user-defined classes. All three different combinations. Okay. In the first example, I already told you typecasting for primitive types. In the second example, I told you the parent and child relationship. And if you create an object directly like this, we can directly access everything from parent and child. But if you create like this, if you are able to hold child object into the parent, then you're able to access only stuff from the parent, not from the child. Not from the child. So that is a limitation which we have. But when to use this one and when to use this one, if you know exactly what type of object it is returning at runtime, then you can specify the exact type. But if you don't know what type of object it is returning at the runtime, then you have to specify the generic type that can hold everything. That is normally object. Okay. Understood everyone? So this is all about typecasting concept. So this much is enough, guys. Okay. No need to go in depth of this. But in Selenium, once you start automation, you will see some scenarios where you will see this kind of a typecasting thing. Okay. There again, I will show you where exactly we use this typecasting in automation. Okay. So now if you have any questions, you guys can ask. So let us stop here for today's session. And tomorrow we'll discuss another topic. We have two more topics, exception handling, and then we have a collections. So we will discuss those concepts in the next session, and then we will finish it off. All right. So that's all. Let's stop recording.